Okay, this is everybody's nightmare. It's a 6-mark sets question, and I know people find sets difficult, so we need to look at how we're going to solve this. Whenever you've got a set diagram where you've got two overlapping groups, you're going to have four distinct regions. You're going to have the region outside, which is all the stuff that doesn't belong to P or Q, either P or Q, but it's still part of the universal set. You've got the stuff here which is just P but not Q. We've got the stuff here which is just Q but not P, and we've got the stuff which is both P and Q. So this is effectively the P intersection Q bit. Now, W, X, and Y and 3 represent the number of elements. We know that the number of elements in the whole group is 24, so 24 is equal to W plus the X plus the Y plus the 3. So maybe I should write that. Maybe I shouldn't write that. W plus X, W plus Y plus X plus 3, that's the total of the group, which equals 24. The number of stuff that is not P equals 8. So the stuff which is not in P. So the stuff that is in P is the stuff inside the circle. That's X and Y. So the stuff that's not in P is 3 plus W. So 3 plus W equals 8. Oh, now here's a tricky one. P intersection Q all complemented. So P intersection Q is the stuff that's in P and Q, so it's Y. If we complement that, we're looking at everything which is not Y, so that's W, X, and 3. So W plus X plus 3 is 15. Okay, now we've got those equations we can start solving. Well, we know 3 plus W equals 8, so that tells us that W is 5. If W is 5, we know that W and X and 3, that's this one here. Sorry, I know that things are hard to read. So 5 plus 3 plus X is 15, which means X is 7. And we also know that W plus Y plus X plus 3 is 24. So we know that W and... sorry, I should write these up here as well. So this is 5, and whoops, that's 7, and that's 5. And we know the total is 24, so that plus that plus that plus that is 24, which means Y must be 9. Okay, now here's some proper heavyweight intersection and complement questions. Uh, Find the number of elements which are in P complement intersection Q. Right, with intersection, you're looking for stuff which complies with the first rule and also with the second rule. So stuff which is not in P and is also in Q. So everything which is not in P is going to be outside the P circle, but it has to be outside P and it also has to be in Q, which means we're just looking at this region. So that's P complement intersection Q, and there's 3 elements there. P complement union Q complement. This is probably the hardest, most confusing type of question you could get. With union, it can comply to either the first rule or the second rule or both. So we're looking for stuff which is either not in P or not in Q or not in either. So let's take a look at the stuff that's not in P first. 3 and 5 are not in P. So that region and that region. If we take a look at the stuff that's not in Q, 7 and 5 are in that region. So if we're looking for stuff that's either not in P or in Q, that covers the 3, 7, 5. It's basically everything apart from the stuff which is in both P and Q. So we got 3 plus 5 plus 7, which is 15. And then we're looking for stuff which is in P and also in Q, because intersections has to qualify both rules, and is also in not P. Well, you can't have something which is in P and also in not P as well, so that's just 0. Coming back to these questions, because these are the most difficult ones, might be helpful to think of these in shading terms. With intersection, what you can do is you can shade corresponding to both. Obviously, it's a bit difficult to do this in exam because you have to unshade everything again. But what you can do is you can shade in everything that corresponds to the first rule and then shade in everything that corresponds to the second rule. So let's take a look at shading everything that is not P. So this is the region that's not P. I'm going to shade it with the blue lines. Yeah, it's everything outside the P circle. And then if I shade in the second rule, which is Q, that's this area here. So with intersection, you're looking for the stuff you shaded in twice, i.e. the stuff that corresponded to the blue rule and also the red rule. That is the only stuff we shaded in with blue and red is this region here, so that's why it's 3. If we then look at the next question, with P complement, U, Q complement, if I do the first rule in blue again, the first rule is not P, so I'm going to shade in everything that's not P. Apologies, my shading isn't ideal. So that's shading everything that's not P, and then the second rule is not Q, so I'm going to shade in everything that's not Q. Okay, now with union you had to shade it in twice. With sorry, with intersection you had to shade it in twice. With union it's anything you shaded either once or twice. So everything that's got shaded at all. So you can see that this region got shaded with red and blue. This region got shaded in red. This region got shaded in blue. So all of those got shaded, which means that we're looking at all of the regions apart from the one which didn't get shaded, which is Y. So with union, you're looking at stuff you shaded at all. With intersection, you're looking at the stuff you shaded twice. That's another way of thinking about it, which can help you get the understanding across.